Good morning. Can you guys hear me? All right. I had some major internet problems yesterday and this morning. I couldn't even teach my classes. So I'm just warning you that if things start going haywire, I want you to go to the Math Wizard teams and work on the assignment. So if I start breaking up and I start lagging and my voice doesn't match my lips and things like that, I may not be able to hear you. So I'm hoping to get this issue resolved either today or tomorrow. I've been talking to a lot of technical people with WebEx, with the district, with AT&T. The issue is not resolved. So who knows what could go haywire right now. I'm hoping that I'm going to be able to teach you guys so I can get a recording out of this lesson for at least period 3, because they didn't get a lesson. Period 4 didn't get a lesson. And so I don't know how things are going to go right now, but we'll just see. So to me right now, just let me know, am I breaking up, or do you have the video? Do you have the audio?
I can see your video and the audio. You're not breaking up.
Okay. Okay, perfect. So I'm gonna try how it goes here. And like I said, if it doesn't go well, just go to the Math Wizard teams and work in your teams, and I'll make sure we're working in those teams until 12:10. So yesterday, I was talking about solving absolute value equations in 2 ways. Using a graphical approach, which doesn't really have anything to do with math, it's using the calculator, and also solving absolute value equations algebraically. So I was almost done with the lesson. I just want to do a few more things, and I wanted to spend time talking in teams today. But I don't know how well this is going to go because of the internet problems that I'm having. So like I said, if I freeze up, if you can't see me, if you can't hear me, either send me a remind or just unmute yourself and hopefully I can hear you, and we'll go from there in the math teams right away. So I'm going to try to get the last part of this lesson. No points of intersection, that means that there's no solutions. All right, so if graphically you have y sub 1 in the calculator and this under y sub 2, solutions, no points of intersection. You're asking me how do you know points are on the graph? If you get your calculator and you go to second graph, you can see the table of ordered pairs. And so you can see what points are being graphed in the table. And you hit second graph for that. There are 3 scenarios that I want to talk about. The first one is, I need you guys to mute yourself if you're not muted. If the value is a positive, it means there's 2 solutions. April, can you mute yourself? If it's 0, that means there's one solution. And if the absolute value is negative, there's no solutions. So I want to do an example algebraically where we're going to solve it. April, can you unmute yourself? I just told you to mute yourself, but can you unmute yourself and tell me if you can hear me and if everything's okay right now?
Yeah, I can see you good. And we
Okay.
can hear you.
Okay, thank you. All right, so let's say we want to solve this algebraically. Remember what I said? You want to isolate the absolute value. Isolate the absolute value. And now we're ready to write a disjunction. However, the absolute value is equal to a negative. And over here I said, if it's equal to a negative, we're not going to do any work because there's automatically no solutions. That was nice. If it had been a positive, we want to write a disjunction, which is an OR.
So I have a question. Well, I'm just confirming. So when there's no solutions, we just write the brackets, right?
Yeah, it's an empty set. It's an empty set. Uh-huh. Yeah. I can't believe I'm teaching.
Wouldn't you have to add the 5 though?
The -5 was being multiplied. Whenever a number is sitting on a parenthesis or a bracket, the only way to get rid of it is to divide by -5. The -5 is not being added, it's being multiplied to the absolute value. Do you see that or no? Can you guys respond? I'm scared now that you're not hearing me.
I'm confused on exactly what we did.
You're confused about that last problem?
No, when you were explaining the -5.
Okay, let me write the problem again. So the problem was -5 times the absolute value of x plus 1, right? And it was plus 2 equals 12, correct? Yes? Okay, so do you see where I subtracted 2?
Yes.
Well, when a number or a variable or anything is sitting on a square root, an absolute value, or a parenthesis, it's being multiplied to it. So in order to undo multiplication, you have to divide by -5. Right?
Yes.
So are we okay?
Yeah, I totally understood that problem. It's just when you were doing the exponent of -5, I was totally confused.
I'm not using exponents. Is that what you said? Exponents?
It was when you were writing the 5. I don't know if it was an exponent or if it was trying to be multiplied, but I got confused at that.
Okay, are we okay now though? Are we all right now? Okay. I'm so happy that I'm actually connecting with you. Not having any problems right now, which is amazing. because these issues have been going on for 2 days. All right, so add 3. So you have 3 times the absolute value of 2x minus 4 equals 0. So it's this case. Okay, now we still have to isolate. So the absolute value is not isolated. He's with them. So what we're going to do is we're going to multiply both sides by 5/3. So we're not going to distribute. You can't distribute across absolute value. You can distribute across a set of parentheses. You cannot distribute across absolute value. You cannot distribute across square root. Can't use for everything. So what happens is we're going to cancel that. The absolute value of equals 0. Now, my little scenario over here, number 2, says that I have one solution. So watch what's going to happen here. I write the disjunction. The positive case is 2x minus 4 equals 0. And the negative case is also equal to 0. So I'm not going to do negative. I'm going to multiply by a -1. And I'm going to multiply by a -1. So see, I have the same exact problem. Why, we're never going to use that. It's always going to be repetitive of the positive case. So now we solve this. 2x equals 4, divide by 2, x 2. So our solution, and where this graph is crossing the x-axis, it's only crossing it at one place. In other words, this absolute value is sitting on the axis at 2. So with the absolute value equals 0, it means the vertex is sitting on the x-axis. And in this case, 2, 0. Okay, so give me some feedback. I did want to go over this, but if you want me to work another problem, I can work another problem.
Another problem should be good.
Okay, I'm going to erase this. Which one of these would you like me to work? Would you like me to work one with 2 solutions, 1 solution, or no solutions?
Could we do the one with one solution?
Sure. All right, so according to yesterday, I said to isolate the absolute value. So we're going to subtract 7 from both sides. And what happens is they both go away. We get 0. So to get rid of the 6 that's being multiplied to the absolute value, we're going to divide both sides by 6. And we end up with the absolute value of 4/3 x minus 2 equals 0. So this is our scenario with one solution. And what it means is that when we write the or, the negative case, let's write the positive case, 4/3 x minus 2 equals 0. The negative case is just going to look like the positive case. So when we solve this, we get 4/3 x, add 2, And remember, we talked about this before. To get rid of a coefficient that is a fraction, we're going to multiply by the reciprocal 3/4. So remember, this is 2/1. So x would be equal to, you can cross cancel here because you're multiplying fractions, 3/2. So the answer here is 3/2. And what this means is that this absolute value equation is crossing the x-axis at 1.5. It's actually sitting on the x-axis at 1.5, 0.
So there's only going to be one solution when the product is 0?
When the absolute value, not the original problem, when the absolute value is isolated and the value isolated equals 0, it means there's one solution. When the isolated absolute value equals than 0 and it's positive, that means there's going to be two solutions. So let me show you the pictures. So what we have here is we have absolute value that's not touching the coordinate, the x-axis at all. That means no solutions. We have a situation where the absolute value is sitting on the x-axis. That's one solution. If you can see this one. And then you have a situation where the absolute value is crossing the x-axis in two places, which means two solutions. So remember that the solutions are where the graph is crossing the x-axis. Those are the solutions. Did you see how I worked through this problem though? Did you see how I did all this?
Yes.
Yeah.
Okay. But conceptually, you understand what's going on, right? When we solve an absolute value, when we solve any equation, whether it's linear, whether it's a quadratic, whether it's absolute value, square root, whenever we solve an equation, we are finding out where the graph is crossing the x-axis. Those are the solutions. Do you want me to do another problem with no solutions?
Yes.
Okay, so with my steps that I gave yesterday, I said to isolate the absolute value. So we're going to get rid of this first. 3 times the absolute value of 1/2 x plus 5 equals -2. We can't say anything right now. We still have to isolate the absolute value. So we still have to isolate it. So when I divide by 3, I get the absolute value isolated equals a negative. So with my scenario written up, I said that if the absolute value isolated equals a negative, there are no solutions. And the reason why is because absolute value always yields a positive, and a positive is never going to equal a negative. So there's no going to do any work. Okay, so far so good. I'm so happy that I can talk with you guys. It's so frustrating when my students can't see me, they can't hear me. It's really frustrating. I know you guys are going through that. So that's why it's important for you to communicate things to me, because unless you tell me, I have no idea what's happening. Okay, I'm going to work one more problem and hopefully I can get through this. And what we're going to do is we're going to collaborate in the teams working on this assignment. If you want to look with me, please, I'm on page 83. I word problems, but I'm not going to test you on them. So I want to do problem number 18, the geese problem. Okay, all right. So on page 83, it says a flock of geese is approaching a photographer flying in formation. The photographer starts taking photographs when the lead goose is 3 feet horizontally from her and continues taking photographs until it is 100 feet past. The flock is flying at a steady 30 feet per second. It says write and solve an equation to find the times after the photographing begins that the lead goose is at a horizontal distance of 75 feet from the photographer. And I don't know about you, but I'm not a good reader. And I would probably have to read that about 30 times. So I would probably have to read it 30 times and try to draw a picture to understand what the problem is actually saying, because there's a lot there. And just reading it the first time isn't going to do it for me. So you might have to read it multiple times also and maybe draw a picture before you even try to start working it, because it's impossible to write an equation if you don't even understand what the problem's saying, like me. So anyhow, what happens here on 18 is this is distance in terms of time. So remember, t is x, d of t is y. Like this, it would be the absolute value of 30t minus 300. Now, 75 says it says write and solve an equation to find the times after the photographing begins that the lead goose is at a horizontal distance of 75. So 75 goes here. And then what we do is we solve this. So we have to isolate the absolute value. It's already isolated. Okay, so after that, we're going to write a disjunction. So the positive case, to get rid of the bars, is going to be 30t minus 300 equals 75. Or the negative case is 30t minus 300 equals 75. So notice there's no bars. So in order to compensate for the bars, we had to write a disjunction. All right, so let's see what happens here. First of all, there's a lot of big numbers. So I'm going to try to simplify this down. So the first thing I'm going to do is I would really like to divide by 5. So 5 times what is 30? 5 times what is that? I think 60. And 5 times what is 7? I think it's 15. And now I notice that I can divide by 3. I'm going to do that because I'm going to simplify. 2 times what is 6? 2 times what is 60? I'm sorry. 3, right? They're all divisible by 3. 3 times what is 6? 3 times what is 60? 3 times what is that? And so that's simplified. So now I'm going to solve it, add 20, and divide both sides by 2. Now we are talking about time. So this isn't a, we're going to have to change this to a decimal. But let's solve the other one. going to give me 30t minus 300 equals negative 75. You're not seeing me distribute the negative. You're seeing multiply this side by a -1, which makes it go away. And I'm multiplying that side by a -1. And if you notice, it's the positive case with this side just negated. So you actually never, if you don't want to, you need to be able to explain it to somebody that's a negative case. But if you never want to write that, that's fine with me. Just write that and just write a positive case and negate the right. If somebody asks you, you could say, well, I'm kind of skipping a step. I'm representing the positive case of absolute value. I'm representing the negative case. This is kind of a trick that I just showed you. So once again, I'm going to divide everything by 5. So 5 times what is that? 6. 5 times what is that? Negative 60. 5 times what is that? Negative 15. And I can divide by 3 again. 3 times what is that? 3 times what is that? 3 times what is that? And now when I add 20, now, that's going to be what, 15? And now when I divide both sides by 2, I get 15 halves. All right, now, since we're working a real life problem, fractions, they make sense to a math teacher. Let's just see what these fractions mean as a decimal. People are used to working it with decimals. So we're going to take 25 divided by 2, which is 12.5. I think you can see this one. 15 divided by 2, you already know what it is. 7.5. So what's really going on here? Well, we would say that the lead goose is at a horizontal distance of 75 feet from the photographer after 7.5 seconds, and again after 12.5 seconds. So that's what we would write. You always want to make a statement to a human being, because a human being is not going to understand this. If you're working for a company that asked you to do this, that nobody's going to understand any of this. So you do want to make a statement about what's going on. The lead goose is at a horizontal distance. Now, you get this statement from whatever they're asking. So if they say, how fast did the dog run down the street? You would say, the dog ran down the street this fast. You know, how many marbles are in the jar? The number of marbles in the jar are. So this came from the question that they asked, or they wanted you to do. They said, so we would say the lead goose is at a horizontal distance of 75 feet. From the photographer after 7.5 seconds, and again at 12.5 seconds. Okay, now the other word problem that I assigned, they actually gave you the equation. See, this one they didn't give you the equation, so I wanted you to see it. But I did, just a reminder, I did provide answers for all of lesson 2.2 in the answer section in Google Classroom. So the book answers, the evaluate problems are on the computer, but those other pages that I gave you, those answers are in the answer section in Google Classroom. All right, this does conclude this lesson for lesson 2.2. And I'm just letting you know that I wasn't supposed to teach 2.1 or 2.2. So I will not be teaching 2.3. And so we'll be having a test on this sometime next week. So it just depends, you know, like I said, I didn't get to teach my period 3 and 4. So I have to be patient with them, but I am going to let them know that this video does exist on YouTube and they can watch the video. So what we're going to do now is we're going to go into what I really want you to do, some problems in groups. I really want you to, if there's a page that you guys haven't, I know I gave you, this. So maybe if you you can start on that, but I really don't want to. I want to collect each other. I really want to go talking out loud, working step by step through the problems, and collaborating. So really, what we're doing, we're practicing talking today. I don't really even care about so much the math that you're just verbalizing. You're talking math. You're saying math. You're trying to use correct vocabulary. That's what I'm really interested in today. Is just hearing you talk. All right. So I'm so happy that I was able to see you. You were able to see me. And I will be joining the Math Wizard teams. Class is over today at 12:10. So you have quite a bit of time to work together. So please don't leave class. I'll be taking attendance and checking back. Do not leave class until 12:10. But I want you to go to those Math Wizard teams now, and I will see you in there. Anybody want to ask me any questions though before we leave?
It's really blurry on my end, just letting you know.
Is anybody else having blurry problems?
Yeah, it just happened more towards the end though.
Yeah.
Okay. So, but were you guys okay mostly through the whole thing?
Yeah.
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 Okay. Okay, if you, in the Math Wizard teams, if you have any questions about, I can problems or answer any questions. Okay, so I'll see you over there. I'll see you in your teams. All right. I'll see you over there. I'm going to stop this recorder.